So thank you, Thomas, for being available for some Q&A about FargoCPT. Maybe you can say a few words about the code first.
Sure. Hello, everyone. I'm Thomas. I was going to present FargoCPT, which is a 2D hydrodynamics code to simulate planet-disk interactions. Unfortunately, my Zoom does not want to let me share my screen today. So we uploaded this video. You can watch it. Feel free to step through it. The code is a descendant of the original Fargo code from 2000 by Frédéric Massey, and then it was further developed by Clément Barouteau, who added essentially treatment of the energy equation. Before it was only locally isothermal, and added self-gravity. And then in Tübingen over the last 12 years, we improved on the code, added more physical modules. Now it's a big package of different physics, multi-physics, including radiation transport, self-gravity. We have a dust module or a particle module to simulate dust. So what we can do with this code is simulate the full range of planet-disk interaction, from very standard scenarios with one planet to very complex scenarios with multiple planets. We have Rebound, the N-body code by Hanno Rein, integrated. So we essentially don't run into numerical issues with the N-body side. Likely your simulation will go boom way before your N-body system will explode. And over the last couple of years, I also had a priority of making the code more usable. So for the end user, you know, it can be a substantial hurdle to compile a code to let it run, especially if it's in C++ and like FargoCPT parallelized with MPI and OpenMP. So there are some dependencies, but now the code should be quite usable. You can actually use it in the cloud. So on GitHub, you can open some code space. That's how the virtual server is called there, and just run the code in a Jupyter notebook. And if you have, like, I think FargoCPT is a good code to run any 2D, that's an important caveat, simulations of planet-disk interactions, how planets shape the protoplanetary disk. If you have some very specific needs, maybe you need to pick another code, but FargoCPT is a good starting point from where you can embark on the journey. And I've used it on one summer school where people actually said, wow, this was way easier than I thought. And it's long tested, so we have many sensible defaults, and it's way easier, I think, for example, compared to Fargo 3D, which is an amazing code, but there you have to tune your setup, your simulation very carefully to get it running. In FargoCPT, it's easier. The defaults are quite sensible, and you can usually just change it with a config flag to change the modes in the Fargo code. Yeah. So I highly encourage you to check out the code, also just play with it. Now I'm free for questions.
Thank you for that short introduction. So I have a couple of questions, but I don't know if anybody else wants to ask some questions first. Maybe I'll start at this point, and maybe people get inspired to ask more questions. So I'm wondering, so if you compare this to the typical runtime with the normal Fargo 2D version, I guess it doesn't change too much the moment you just have, let's say, 2 or 3 planets compared to 1 planet, right?
Well, the runtime completely depends on your grid size, so the number of cells you use for the hydro simulation. And there it scales better than, I think the original Fargo code was only parallelized with OpenMP. That means only threads, so you have only one computer essentially. And our code nicely parallelizes to like 10 to 20 machines, because it also works over the network. I mean, there's some penalties, of course, versus one machine only, but that works rather nice. We can go up to like 32 or 64 cells per scale height, so thousands of cells in each direction. Of course, then because of the CFL, your simulation is slower, but we can do that.
Yeah. Oh, super cool. Any other questions from the audience in the meantime? Diego has a question. Yeah, please.
So you say that you integrated with Rebound, which offer different integrators that you can use. I couldn't finish watching the registration, but of your presentation, but I saw that you also have binary systems. So I was wondering, it is also configurable which integrator to use. If you want to put like second binary planets or something.
You can configure it. The standard integrator we have is IAS 15. So
okay.
15th order integrator, which is enough for everything, only not if you have close encounters. But then if you have a close encounter, I wouldn't trust the simulation anymore, because then the length scale you resolve with your n-body simulation is much smaller than the hydro scale typically of one cell. So then you run into some consistency problems, I would say. But you can change the integrator. You would need to change the source code, but it's just the enum statement when rebound is called. So more or less they're completely separated and only have one point where they contact, and there you could specify another integrator. And circumbinary planets work very well. And we have actually a special treatment of the fictitious forces, which are especially suited for binary star simulations. Although you need to have extreme systems for that to really matter. But that's certainly possible. Circumbinary planets would be a good fit for FargoCPT. And maybe one thing to this also, you can also select to center your hydrogrid on the center of Mars rather than on the primary star. You can also choose the secondary star as your center, depending on what you want to do. But for binary systems, usually it's better to have it in the center of Mars, and that you can also do.
Very cool. This basically means you could also do go for moon forming disks in that direction. Cool.
Yes, you should be able to do that. You could simulate I've never done that actually, but you could simulate a circumplanetary disk in a gap, for example. Yes.
Okay, perfect. Any other questions? No, this does not seem to be the case. So thank you, Thomas, for taking the time.
Yes, pleasure. Thank you.
Thank you. I will stop recording now.